Everybody, we are on page 465, rational functions, lesson number 4. So in the last lesson, we looked at functions like this. So this is a rational function. It has variables in the numerator and the denominator. And we learned that anything that makes the denominator 0 was our vertical asymptote. So for this function, we want to say we have a vertical asymptote at x equals 3. And I have that function graphed here on Desmos up in the corner, and you can see if this is 3, well, there's 3. It would be a vertical asymptote going up and down. Okay, that makes sense. However, if you look at the graph right beside it, this one, it also has a denominator where x equals 3 would make it 0. So you want to say it has a vertical asymptote. But if you graph that function, right? So I'm going to take this 2, change that to a 3, and then you look at the graph, it's a straight line. Okay? Now, if we pull up this tools, there we go. Sorry, people. If we look at putting in -3 here, we get, 3. My mistake. The function is undefined. Okay? So what that looks like is on the graph at x is equal to 3. So this point right there. Okay? You can't see it on this graph, but it would have a hole in it. So at the bottom here, if I graphed this, which is this function, I'll write it down here. Y is equal to x squared minus 4x plus 3 over x minus 3. Why does it look like this? It's a line, but at 1, 2, 3, it has a hole. Okay? It's an open circle. It's a hole. It's called a point of discontinuity. Does not exist. It's not a vertical asymptote. It's a hole in the graph. Why is this a line, whereas the other one had a vertical asymptote at 3? It looks like this. Okay, this was the graph of y is equal to x squared minus 4x plus 2 over x minus 3. We had a vertical asymptote. This one does not have a vertical asymptote. They both have denominators of x minus 3. So what's different about the second one here? Well, just like everything in math, if you factor this top, what multiplies to 3 and adds to -4, x minus 3, x minus 1, you have an x minus 3 in the denominator, so they cancel. You're left with x minus 1. And x minus 1, as you remember hopefully from math 10, is a straight line, has a y-intercept of -1, and a slope of 1, because there's a 1 in front of that x, up 1 over 1. Remember, this is a straight line of the form mx plus b. Okay, so when a factor cancels, x minus 3 in this case, you get a hole, an open circle in the graph. And that's what this whole lesson is about. So here's our two functions. X plus 2. Well, if you remember, mx plus b is your y-intercept. So this has a y-intercept of 2, so you mark 2 as your y-intercept. The slope is the number in front of x, m. It's a 1 in this case, and if you remember, slope is rise over rise, so we go up over 1, up 1 over 1, and we draw a line. Second one here, whenever you have something that is written as a polynomial, always factor it. So we go what multiplies the 2 and adds to 3. X plus 2, x plus 1 over x plus 1. The x plus 1's cancel, and we get x plus 2. Now, that is the same as this, with one difference. This x plus 1 here in the denominator means you cannot have x equaling negative 1, because that would make the denominator 0. You always have to go by the original. So the domain of this, or the restriction, is x cannot equal negative 1. So at negative 1 here, there's negative 1. There can be no x value. Sorry, I shouldn't have circled it on the thing. So we draw the line x plus 2 up to, start at y-intercept of 2, up 1 over 1, down 1 over 1, down 1 over 1. And you want to draw this line, except x cannot be negative 1. So we have to put an open circle like that. So these two lines look the same, except this has an open circle at negative 1. X is equal to negative 1. If you want to find the y value, you can see it's 1 here. But to find the y value of that undefined point, or the POD, this is called point of discontinuity, which we will call POD. Put in what x cannot equal into what's left over. So negative 1 plus 2. So y cannot equal 1. And that's what that is right there, 1. So the POD has a coordinates of negative 1 for x and 1 for y. Okay? All right, so we're going to go down to the bottom. Actually, we're going to skip to the next page. This just talks about how to find PODs. Factor is always the first thing. Simplify by canceling, and then plug the non-permissible or the domain restriction. When it says non-permissible, it's what x cannot be, is not equal to. All right, so we're going to do a lot of practice here. We have f of x is equal to x cubed minus 7x plus 6 over x minus 1. Now, to cube it, normally you would have to use what we did last chapter, synthetic division, test to see if the remainder is 0. We're not going to do that. I am going to tell you that this gives a factor of x minus 1 and x squared plus x minus 6 over x minus 1. Okay. Factor the quadratic here. I know you can cancel the x minus 1's, but we want to factor this. So what multiplies to negative 6 and adds to 1? So add to that and multiply to that. That hopefully you got x plus 3 and x minus 2 over x minus 1. Okay, so now you cancel the x minus 1's, and you're left with x plus 3, x minus 2. So we have a POD that x is equal to 1. That is what makes this 0, the thing that canceled 0. If you want to find the y value, y value will be put 1 into these, what's left over. 1 plus 3, 1 minus 2, that's 4, and negative 1, so it's negative 4. So the coordinates of the POD are 1 and negative 4. All right, POD. So if I asked you to graph this, coordinates of the point of discontinuity, that's what we just did right there. We have x plus 3, x minus 2. This is the same as x squared plus x minus 6, which is a quadratic, which has the shape of a parabola. But it's better to have it in factored form because those are your x-intercepts. If you remember from the last unit, yes. So x-intercepts, or the zeros, are negative 3 and 2. They mark negative 3 and 2 on the graph. Has a positive leading coefficient, it's 1 here. So then, and it's even degree, so both arms are up. Remember, at the coordinates 1 and negative 4, and just guess where negative 4 is. We have a hole. So the graph comes down. Oops. Erase this, sorry. The other thing we should note is the y-intercept. Is when x is equal to 0. If I put x is equal to 0 into this equation, I'm left with negative 6. So negative 6 is the y-intercept. So there's my hole. Comes down, goes through the hole, and goes like that. And this is my POD. So there's a hole in the graph of this parabola. They don't just have to be straight lines. They could be any graph. It just will have a hole with wherever the factor cancels. Okay? All right, one more. So again, a cubic. I'll start the factoring of this for you. So we are going to write it out as equal to x plus 1 2x squared minus x minus 15. On the bottom, we can the quadratic. This would be good practice for us. Okay, so there's your function. The first step is to factor everything. Okay? So step 1 is factor. So I need to factor the 2x squared minus x minus 15. So the way I do it is I multiply 2 times negative 15 and I get negative 30. And I ask myself what multiplies to negative 30 and adds to negative 1 there. Negative 6 and 5. So this becomes 2x squared minus 6x plus 5x minus 15. Bracket the first 2, take out a common denominator, which is 2x. Second 2, I can take out a 3, or a 5, sorry. So I get x minus 3. You know you're doing it right when these brackets match. You essentially factor out the x minus 3's. And I got 2x plus 5. So that means this bit here now becomes x minus 3 plus 5. Okay. Now we have to factor the bottom. Green. So this needs to be factored. So 2x squared plus 7x plus 5. Remember, first number times the last number gives me 10. What multiplies to 10 and adds to 7, 5 and 2. So I write it as 2x plus 5x. Bring down the other stuff. Bracket the first two, take out a common factor, in this case 2x. Take out a 5 in the second one. Whoa. Oh, because that is a 5, so that would be a 1. There we go. So you know you're doing it right if the brackets match. And then I get x plus 1 times 2x plus 5. So on the bottom is x 2x plus 5. So it looks like we have two things that cancel. And I'm left with x minus 3 is my function. Okay, that means we have these. X is equal to negative 1, this, and x is equal to 1. If you solve that, set it equal to 0, you get x is equal to negative 5 or negative 2.5. Okay, and this is a linear line. So, we're going to make a sketch of the graph. So let's figure out all the coordinates of the points of discontinuity. So when x is equal to negative 1, y is equal to negative 1 minus 3 is negative 4. So the coordinates of one of them are negative 1 and 4. Remember, you just plug it into what's left over. When x is equal to negative 5 halves, I'm going to do it as a fraction. You can do it as a decimal if you want. Y will equal negative 5 halves minus 3. Make a common denominator. So the 3 becomes negative 6 over 2. Subtract the exponents, the numerators, negative 11 over 2. So the coordinates of that point of discontinuity are negative 5 halves, negative 11 over 2. All right, and then we're graphing x minus 3. Let's write it down here. Remember, it's mx plus b, so my slope is 1, and my y-intercept is negative 3. Y-intercept of negative 3. If I go rise over run, basically it's going to look like this. Then I'm going to mark in my points of discontinuity, negative 1, negative 4. So if I say that's negative 1, I'll say that's negative 4. There's my point of discontinuity. And negative 5 halves, so negative 2.5. And negative 11 and a half. There's my other one, negative 11 and a half. So the thing is here, you can have more than one point of discontinuity. You can have an infinite. It's just whatever factors cancel, that is the point of discontinuity. All right, the questions I want you to do, questions numbers 1 to 5, basically you're going to do what we did here. You're going to factor everything and sketch the graph. All right, now number 1, 2, and 3 are straightforward quadratics. Okay, this one I'll tell you right away. Factor out a negative and reverse it. So if you take a negative out, you're going to get x squared plus 2x minus 50. Factor that. Plus 1. Okay. That one you can factor quadratic again. And just sketch the graphs right there. Don't worry about domain and range. For number 4, it's a cubic as you can see. But you can rewrite it as this. E of x is equal to negative x minus 3. And instead of a cubic, we will write 2x squared minus 8x plus 4 over the other quadratic. So go from that starting point and sketch it. Again, don't worry about domain and range. Just give me the points of discontinuity and the sketch of the graph. And for number 5, you can write it as the numerator will be 2x minus 3 equal to x squared minus x minus 6 over 2x minus 3. Okay, so go from there as a starting point. So just 1 to 5, figure out the points of discontinuity and sketch the graph with the holes in them. I want the x and the y intercepts. Okay. Good luck, people. There's only one quick lesson at the end, and this unit will be over. Good luck.